Have questions as necessary. For this, you were just supposed to demonstrate that you could get two different results in some fashion. So you didn't necessarily have to do what I did, but if I went approaching 1 in a kind of exponential way, I want to be close to 1. I'm going to approach from above. An exponential way means in a power varying kind of way, so maybe 1.1 and 1.01 and 1.001. It's not really exponential in a fashion, but you know what I mean. Linear, I need to get bigger an exponent, but in a really, I think of it as a slow way. So maybe to some power and then increasing in a linear way. So anything like that would do. It doesn't have to be that. But I could do that without a calculator. What is that approaching? What are these getting very close to? 1. Yeah, I mean, if you thought of 1.001 times itself 12 times, that's pretty much just 1, yeah? Okay, now that one kind of confirmed what I thought. 1 to more power should approach 1. However, if the base got approached 1 slowly and the exponent grew quickly, you could get something else. So say you approached 1 in a slow way. Tell me how I can approach 1 in a slow way. 1 and maybe 1.5. What can I then do to get closer to 1, but a little slower? 1 1/3. Okay, that's what I'm talking about. Linear. Obviously, that's not really linear because the difference isn't the same, but I'm thinking the denominator is a linear pattern, right? The exponent, I want to get bigger in an exponential or quickly growing way, so I'll give you some exponents. 10, 100, 1,000. Now, despite the fact that the base is getting small, the exponent is getting so big so fast that it's going to be really powerful. 5/4 to the 1,000. What would that be? Really, really big. I mean, so big, in fact, that I screwed up and I thought I saw like a 3 there, and I didn't even see at the end that it was like times 10 to the 12. It's huge. I mean, it's huge. It's really, really big. So this actually approaches infinity. That is to say that it doesn't matter if the base goes to 1 and the exponent's getting big, if I can't figure out what rate they do their things. Depending on the rate at which they approach 1 or approach infinity, you can get some vastly different results. Are you with me? Great. Okay. So on this here, let me get this. Where did I put this? Let's see. Sorry. I put this away. Where's the key? Oh, here it is. Okay. All right, so this one I had was infinity, 4. This was 0 to the 0, which is indeterminate. 6 was negative infinity. Do we all agree on the first one? Okay. 7 was 0 to the 0, which is indeterminate. This one came out to be infinity plus infinity, which is not indeterminate at all. Infinity plus infinity is big. And infinity to the 0 is indeterminate. Second row, do we agree? Any questions about the second? Okay. Third row. This came out to be infinity minus infinity, which is an indeterminate form. It would depend on the rate at which they did their thing. This one was infinity to the 0, which is an indeterminate form. And this guy goes to 1 to the infinity, which is also indeterminate. How do these all look? This is the easier part of the problem, I think. Okay. All right. So the last page was where the hard stuff comes in. Let's go through these. Actually, I'll give you the answers, and then we can go back over any questions you have. For the first one, I got to do 0 to the 0, which is indeterminate. And after doing the limit, then 1. Now, number 2 was actually pretty rough. Number 3, I got infinity to the 0, which is indeterminate. So after doing the exponential and log work that we learned yesterday, the limit was also 1. Success? Okay, if not, then we'll go back over it. Number 4, I had a lot of disagreement on in the last class. I got one that approached the form 1 to the infinity, which is an indeterminate form, and the limit is e to the 4th. Number 5, that approached infinity, which is not an indeterminate form, it just approaches infinity. That's the limit. No L'Hopital work. If you did L'Hopital work, you're wasting your time. All right. Number 6, it was a 0 to the 0 form, which is an indeterminate form. The limit is 1. Number 7 was a 0 to the 0, which is an indeterminate form. The limit to that was 2. I should have given you 7 or 8, not 7 and 8. There's 90% overlap there. I don't know what I was thinking. Oops. 8 was infinity to the 0, which is different, but all the work to find the limit was the same. It's 2. 9. 9, upon inspection, goes to 0 to the goes to infinity. Small numbers times themselves over and over again. Is that indeterminate? No, it's just 0. Okay, that's not indeterminate. Tiny numbers times themselves many times approach 0. Okay, 10, 0 to the 0, which is indeterminate. And after evaluating the limit, twice I had to do L'Hopital. Lame, that was terrible. The answer was 1. And 11, this is not what I intended. I wanted this to be a really clever problem, and then I screwed it up. It is getting huge to getting huge powers, which is, in fact, getting huge. Not really determined. That was all right. Questions on any of those? 2. Okay, start with 2. We can get 2 and 6. 2, 6, and 10. And 4. 2, 4, 6, 10. It's almost as if you had the odd answers, but you didn't, right? It's weird. Okay, 2. So, I've had with discussions with students both today and over the years that there's certain common mistakes. So I'll try and see which you're going wrong here. All right. So most people in the last class did not have a problem with the first step, which is to determine if it's indeterminate. Are we cool with that part, 0 to the 0? Okay. So let's go into the hard part then. E to the limit as x goes to 1 of the natural log of the natural log of x to the x minus 1. I think in this class we discussed that the log rule doesn't apply, that we can't just bring that x minus 1 down as it is because it's not on the x itself, it's on the whole thing, and that log rule doesn't apply. So you actually do need to take another log. It's not a case where you can bring down the x minus 1 already. Okay? If it had been this, could I have brought that x minus 1 down? Yeah, that would have been a lot easier, darn it. All right, so we're there. When you bring that x minus 1 down, I'm showing a lot of steps. You could definitely combine a few of these steps. Okay. We talked yesterday about how we need to see how this goes by looking at the rates of change, but finding the product of the rates of change doesn't tell me anything. I need to compare the rates of change. So you've got to make this a quotient. You have to make it a quotient. As much as it makes it much uglier, the whole principle of L'Hopital, comparing rates of change, depends on there being a ratio there, not a product. Okay? Second thing, and this also is a very common mistake. When I go then to take derivatives, do I use the quotient rule? No, okay? Because that would really be the rate of change of this whole thing, and L'Hopital works as a comparison of their two rates of change. So don't think quotient rule, think derivative over derivative, comparing their rates of change, okay? So when I take the top derivative, it's 1 over natural log of x times the derivative of the inside, which is 1 over x. The denominator derivative is -1, x minus 1 to the -2. Stop me if you disagree with my L'Hopital. All right, now, there's almost always going to be some cleanup to be had here. You're going to need to clean this up before you go evaluating. I could call this negative x minus 1 squared in the numerator over x natural log of x. At that point, before I write anything, I just mentally say, all right, where am I at? What does the numerator go to? 0. What does the denominator go to? 0. I agree. And so it's an indeterminate form. There's not really any canceling to be done to deal with that. So what do I have to do? L'Hopital again. Now, this is not, just so we're clear, I said yesterday you don't have to keep showing it's indeterminate all the way through. When I said that, I mean all these forms. These are all equivalent forms. I haven't done any L'Hopital here. But now, this is really different than the previous one. So in terms of showing work, you should do that. What the heck is that? You should show that negative x minus 1 quantity squared is going to 0, and x natural log of x is going to 0 to justify what you're about to do, which is to L'Hopital again, by L'Hopital again. E to the limit as x goes to 1. And by L'Hopital, it has something like negative 2, x minus 1 to the first, over x plus log of x. Okay, so let's see where we're at now. At 1, where's the top go to? 0. Where's the bottom go to? 1. We're golden. Okay, so it's e to the 0 over 1, which is where we're getting an answer of 1. Okay? Questions about 2? I wish I would have put that later in the game. That was pretty hard. That was one of the harder ones. Okay. You said 4. Do we still have a question on 4? No. Anybody who want 4? Talk up, man. This is what the same questions they asked. If you have a question on 4, okay. Thank you. That's the spirit. Okay. Do you agree with 1 to the infinity? Yes? No? Do you agree with this step? Ty, did you do this problem?
I did this step, yeah.
Do you agree with 1 to the infinity?
Yes.
Okay, cool. Now let's go to the second part, which is the indeterminate form part. In terms of showing you what kind of work, I would be actually fine if you combined a little bit of the first step. I don't need you to show the natural log, then show the exponent coming down. I would be okay if you took the natural log of this and at the same time brought 2 to the x down and wrote it as a quotient. So if you did all that together, I'm okay with that. Let's save ourselves some time, okay? Okay, so thankfully, because 2 to the x is always already a fraction, this is already a quotient. I didn't have to do that step with making it a fraction. It's already a fraction. So I can just L'Hopital now. I get 2 over e to the x plus x times the inside derivative e to the x plus 1 all over 1. Let's try a mentally direct substitute. The top would be 2, yeah? In here, times 2. So I'm looking at a 4 over 0 or over 1. So I'm golden. It looks like 2 times 2 over 1. That's where I got e to the 4. Okay? Okay, 6. Anybody have 6? Okay, 6. All right. Do we agree with the first step, the 0 to the 0, that it is indeterminate in that form? Okay, so we'll go to the second part. All right. So this is definitely one of those ones where it feels so weird to make it a fraction, but it's the way it is. When you take the log and you have x minus 4 in front, that is obviously not a fraction. To use L'Hopital, it's got to be a fraction. I cannot remember any case where I've ever put the natural log in the denominator. I almost always, the base or the natural log will always stay in the top, and it's the exponent that gets moved to the denominator. So x minus 4 to the negative 1. Cool? Okay, by L'Hopital then, the limit as x goes to 4 from above, I have 1 over 3 times the quantity x minus 4 times the inside derivative, which is 3. The 3's would divide away. The denominator derivative is negative 1 x minus 4 to the negative 2. Okay, that seems like it is okay. Now, obviously, I don't want to put a 4 in again because I'm going to have zeros all over the place. Let's do some algebra. If I bring the denominator up, it becomes negative x minus 4 to the positive second over x minus 4. We can divide it out, and by dividing it out, it allows me to, oops, I lost my e. I never had an e. Oops, sorry about that. Okay. After you've dumped that x minus 4, the whole that's kind of in that graph is gone, and it becomes just e to the 0. Can you can, no. Oh. Whoa. Oh.
Not like,
no, no.
not like after the beginning, but after the natural laws.
Oh.
You can't do that.
Oh.
Only one making a lot of concerns.
Never mind.
What was your question? What did you say?
Okay, after your natural laws, and you bring down the x minus 4, can you take out that 3 and put it in front of like the limit?
What about the fact that it's in the natural law? So it occurred, I don't know if I never occurred to me, but I don't think it fit me in the church, but this x minus 4 is not just the exponent of x minus 4, it's the exponent of both, right?
Yeah.
It didn't occur to me. Did that, but it went away, so we're okay, right?
Yeah.
Okay. I felt like because I didn't understand that x minus 4 was also being exponentiated, that I might have missed a step, but I lucked out basically. Okay, never mind. Forget all those O's. Are we cool?
So just no, you can't.
I can't remember your question. Okay.
Never mind.
Okay, cool. All right, thanks, Glenn. Number 10. Question on 10?
Yeah.
Okay, cool. Do we agree with the infinity to 0?
Yes.
Okay, so we're good on the first step. Sounds like we're rock solid there. Okay, do you agree with 0 to the... Now! You're stupid! Sorry, I'm rusty too. Golly. Do you agree with 0 to the 0?
Yes.
Let's go to the solution. So e to the... All right, so I get x natural log of cosine of pi over 2 minus x. Do we agree with that step? I took the natural log, brought the x down. Okay, so you must make it a quotient. So I assume that you did not make the mistake of taking derivatives before you had a quotient. You moved the x to the denominator. Yes.
Can't you turn cosine of pi over 2 minus x cosine of x?
Oh, wow, that would have been great. I wish I would have thought of that. Should we go back and do it that way?
Yeah.
That's super smart. Yeah. Fundamental rule of math is, can you make your life easier first? And that's a great idea. Way to go. I am not, I gutted it out, and I think I got it right, but man, I made a mistake. Good call. You are the student of the month. Well deserved. Well deserved. Okay.
I just remember all the easy stuff.
You did that? Oh, I wish I would have done that. If you want to see it the other way, you can look at my key. If you did it, if you want to see, if you didn't do that and you want to see where your error was, I can show you my key. Okay? All right. Wouldn't you say then that this becomes this? Oui? Okay? By l'hôpital, we'll go with 1 over sine times the inside derivative cosine, or cotangent. Negative x to the negative 2. No matter what, though, you still had to do this twice, didn't you, Al?
Yeah.
Okay. So when you break this up, you get negative x squared cotangent x. Do you agree? Okay. Now that is an indeterminate form because that's 0 times negative infinity times infinity from the positive. 0, negative, whatever, 0 times infinity, it's indeterminate. You should, in terms of good work, you should be showing that. X squared goes to 0, cotangent of x goes to infinity. So by L'Hopital, actually, before I use L'Hopital, I would have to make an quotient. This is negative x squared over tangent, which by L'Hopital is equivalent to negative 2x over secant squared. Wait. Yes, Hibby. You don't have to show this. Is that what you're saying? Okay, now, yes and no. I said that in the original problem, after you've done all this stuff, you've brought it down, so this right now is a product indeterminate form. This right here is a quotient indeterminate form. I don't expect you to show this because all these are mathematically equivalent. Without any calculus, they're exactly the same as the other. This, however, this is after L'Hopital, so this expression is not really equivalent to that one. This is to me, a new L'Hopital problem. So in good work, I would expect you to show it. Okay? So that becomes something like e to the 0 over 1, which is cool. Any other questions on this pink sheet? Cool. All right. Get that to me by the end of the day. On the homework for tonight, there are 2 things I want you to change, or I have typos on of some sort. Would you go to 23? 23, I want you to change 2 things. First of all, add in the condition that time is positive. Number 23, right, time is greater than or equal to 0. Sorry, that's not positive, that's non-negative is what I should say. Time is non-negative. Okay, also, would you change that to t squared, not t to the first? I don't know what I was thinking, that's dumb. That should be squared. Okay, that is that. This is meant to be practice on BC calculus material that you have seen recently or at the end of last semester and get you back up to it. Let me know if you have questions.
That's I scribbled
Yes.
Yeah.
So, second problem is indeterminate on the inside. How do you express that?
Yeah, so a couple different schools of thought. One person just said, well, geez, it's super indeterminate. Indeterminate inside. My intention was that you could just use in behavior and just think of that as 1 to infinity. That's but either way, it's indeterminate. Infinity, you go 1 to the infinity is indeterminate, or infinity over infinity inside is indeterminate.
I'm just going to ignore my work, but on number 6, no, number 8, what was the answer?
8 was 2.
It was 2?
2.
Oh, that makes sense. I got E to the L and 2, but...
Oh, yeah, that'll be 2. Yes, do that. I have some of the first ones done. In the last class we reviewed those a little bit. Number 7 was a little. You want to?
Yes.
Yeah.
Okay, let's do 7 together, shall we?
Yeah. Let's do
7's the hardest one.
Oh, and finding the areas.
Yes, we'll do 7 and then 7B in the next one. Yeah. Good question. Okay, so 7. 7 is to graph, what's the equation? 3. Okay, so what in this tells you it's a rose, first of all? The 5 theta, okay. A rose is a trig expression with the argument in the trig function, or a coefficient to the argument. So, how many petals? Okay, remember there's 2 rules. If this coefficient is even, then the number of petals is double that. But if that number is odd, then the number of petals is that. And so how many petals are there? 5. If it's sine, what symmetry is there? Along the y-axis. Okay, symmetry, y-axis, 5 petals. What does the 3 do? All right, so length of the petals, the max length is 3. Now let's talk about details. The first thing I find is the first petal. You get the tip of a petal when you are going out. Remember, R is not about horizontal or vertical, it's about how far do you go from the origin. A tip of a petal happens when R is at a max. Okay? So the first petal will be when this is at a max. This would be at a max when 5 theta equals 5/2. Now this, I love that you do this in radians, but these are the one case in calculus where I think it's better to do in degrees. When 5 theta equals 90. So the first petal is at theta equals 18 degrees. Now remember, you're given 30s, 45s, and 60-degree multiples in a polar graph typically. Many graphs, many teachers or tests will have every 5 or 12 or 15 degrees given. Those are actually pretty nice too. But this is pretty cool. All right, so 18 degrees, I think you'll agree, is to go 3 units out and about here. All right, then. The next thing I do is the spacing. We said there were 5 petals, so what's the spacing between the petals? 360 divided by 5, so 72. So if the first is 18, the second will be 72 from that, so 90. There's that symmetry at the y-axis. The third will be 72 from that, so 162, which I don't really have to worry about placing because I know it should be symmetric to this petal 1. Yeah? All right, the fourth, I'm going to have to do some work for. What's 72 from 162? 234. Now, the degrees around here, what are the degree marks around here in the third quadrant? Stay here. 225 is the middle. 210 and 240. Actually, it makes me a little happy that you don't know the degrees ones anymore, that you only know the radians. All right. So 234 is going to be right around here, just shy of the 240, and that actually also gets you the 5th petal because it'll be symmetric. The equal axis, it'll be something like that. Okay. Do you understand the graphing, or does that refresh your memory a little on the graphing? Now let's talk about the area, which is the problems below this. I guess it would be whatever, 8b maybe, or 8d, something? I don't know. Whatever. So are you with me? You know where I'm at? We're going to find the area in this. The area generally is 1/2 r squared d theta, and it comes from summing many sectors or triangles, depending on how you look at it. I know there's an r in there, but really theta is the variable of operation. Here it's d theta. You use symmetry. Now, I would look at this and say, I just want to get the first part of 1/2 of a petal. That much, and I'll just multiply it by a factor of 10. So I'm going to take 10 times 1/2 blank squared d theta. The r, rather than use r, I'm going to use the equation, 3 sine 5 theta, so it's in theta terms, because the integration, the variable of integration is theta. Cool? The hardest part by far is the limits of integration. I need to know, remember, you're talking spokes when you do theta. You need to figure out where's the first theta, and then the last theta of that section. Where does that region start off with? 0. And it ends at 18 degrees, but now we're going back to radians. So what is that in radians? Yeah, when would that happen when 5 theta equals 5/2, which Is that pi over 10? Calculate that, you can use your calculator.
Wait, could you do that part one more time?
Sure. So I'm trying to figure out where this part of the rows was made, what angles. Now I know that sine starts at 0, so the start of that pedal started at 0. And as theta gets bigger, I'm going further and further and further out. So I'm making this curve starting at theta and going until I reach that furthest out place. With me? Now, it's at its furthest out place when the sine is at a max. When is sine at its greatest value? When you take the sine of pi over 2, right?
Yeah.
Okay, so this would be at its greatest when 5 theta is coming out to be pi over 2. Well, that would mean theta is pi over 10. That's where this last piece happens. After pi over 10, it starts to come back. So that's why it's 0 to pi over 10, because that's where,
And you know it's 0 just because it's at the origin.
because sine starts at the origin. Yes?
Is it always true that without the 10, that it's just finding half one of the pedals?
Without the 10, this would be finding 1/2 of one pedal. If you, in what case, what do you mean? Sorry. Without the 10, this would absolutely be half a pedal. Yes, that's true. Okay, yes. And I actually could have gone a lot of ways. You're right.
You just multiply the whole angle by double.
The number of pedals times 2. Yep, exactly. You got it. Yes. Okay. Let me know if I can help you or if you need review on anything else.
What was the answer to 7 on the cheat sheet?
7 on the sheet.
For you got like natural log of
7
I got E. Yeah, I got E. It's hard to read my book because it was winter break. It was winter break.
You never knew how to write, did you?
I did it. I'll write it on a sticky note. And I used a sticky note. I'll show you my thought process. Oh, you are?
I should look at the blue, right?
No, the black is the actual secondary. I was the one, so I'll tell you.
So, this my issue right there is,
Oh my gosh.
what's up this is 1 plus natural log of x. Right. So what about that?
Tears. Okay, did you miss that?
Okay, so then 1 plus natural log of x. So you get 1.
So that would definitely be the term of natural
But then when you do love and tally, you're getting like more and more and more.
So you'll clean up as you go. No, you clean up each time. So the first time, you would have, where am I picking? That first term, there would be natural log of 2 times 1 over x.
Yes.
For the numerator.
No, times 1 over x.
Times 1 over x. Now if you then clean that up,
No.
it's natural log of 2 over x times x over 1. So isn't that e to the limit as x goes to 0 of natural log of 2? Which is natural log of 2.
So just 2.
Yeah. Okay, so clean up as you go. Definitely don't keep taking derivatives. Always do clean up after each step. Okay? Just clean it through. Okay.
Here's this.
Oh, thank you.
We've been told for years, don't cancel these out.
Strangers.
Yeah, well, you can put it in here anyway.
20. How many people? Bab is absent. Namaka is absent. We should have 21, and I do have 21. Ow. Yes, I am.
Yeah, but it's still 1 through 10. Just do a public service announcement.
Yeah.
Number 2, the insight goes to 1. Just do that.
There you go.
I know I didn't. Honestly, this is video.
You still like it?
Yeah.
They do.
Wait, Mr.
Yes, there you go.
Birthdays.
So would you be X and Y plus 1 for me? Oh, yeah, you think it's a good idea?
Well, I mean, you gotta look at this.
Also, what were you looking at? Zero.
I got you.
Key to that second review here, if you want to check your answers.
It's one of these. How do I fix it? Oh, I don't think I can fix it anymore. That's your name. Zero. Yeah. Oh, that was such a smarter way to do it.
You can do it that way.
No, but it's all wrong. This person I know forever.
Oh,
You don't have to do I just figured it out.
you're all set. If I had any money, you'd be all set.
Clearly, you can separate like the.
Oh, right.
You don't have to do the large portion. Separate it. What you do is you.
Which is just zero. So when I
Okay, then take that.
4. Sorry. Confusion.
1 plus 9.
it's okay.
Okay. Oh, something else.
I separated up. Separated up. It's just a lot.
Check it out. It didn't really great. What is that?
Just a little.
Wait, never mind, it doesn't make it.
Pretty much. Everything else goes to infinity, 1 over x goes to 0. So it's not infinity or 0. So the first thing is infinity. The second term is negative natural x.
No, it's also area. It's negative infinity plus infinity.
But,
The first
oh,
pedal's
wait,
on zero.
But they're
natural
different
x.
infinities.
Wait,
I think you have to combine them.
So wait, no, it goes to negative infinity.
I thought the cosine was first.
No.
So it's infinity times negative infinity.
So then when you bring up the negative.
Yeah, so it's negative, or no, this is.
Oh, yeah.
That's infinity. It goes to You don't have to do this. Oh, wait, no. Yeah, on the first one. No, wait, you don't have to do this. No, I didn't do it at all.
That's the point of it. Because then you get the first one.
No, because you go into infinity. So you go to 0 and stuff in the denominator, but you go to infinity. It's not one of the terms. So it goes to infinity as the above goes to infinity. It's like that. I'm trying to think though, but I can't think of the second one. Because that goes to.
For number 2,
That is awesome.
you have to look up.
It doesn't actually have a loop.
Isn't it just negative infinity?
Hey, Laura.
But they can't just say like infinity over.
Yeah, be right there.
Oh, okay, infinity over 0, where's that?
I don't know, that's not.
Wait, no, here's what I was thinking. So I got that. I separated the I separated the exponents.
Oh.
And then like I turned that into negative.
But this, you cannot.
Wait, you can't.
Isn't so what is x to the a minus b?
X to the a minus
X.
x.
Oh, you said x to the a Time, oh, I guess you did. So you did it that
Yeah,
way?
that's what I did.
Okay, that's fine. So,
Okay.
okay, let me see.
And then so I considered it that I was doing the same thing so the natural log of x goes to 1, and then x to the negative 1 goes to 2. And then that's in the bottom, so that goes to infinity.
Wait, are you recording?
This thing, basically, the bottom goes to 0. So that makes sense. Wait, e to the negative infinity, that gets to 0.
Yeah.
So 0. Oh, and then that turns into, right, oh, that's right. Yeah. That makes sense.
We're going to math and you're right over 2.
Max is at That's the minimum, but there is that 5 or 2.
Is it though? So wait, I could be higher versus yeah, that's check it on the notes.
Yeah, 0.
You get
I
negative
didn't want to get our number 2. And like,
No, I think 0, but I think I got one.
it was number 2.
well, I had low-key call
Twice? Did you do twice?
Mike,
Hi, I have a question.
sure, I did.
Yeah.
For number 2, I got like 9 points with this answer, but I think it was I run around and
Number 3 is the correct
and
one.
then you
number 3 is
Yes, it is number 3.
9 points for 5.
Hi.
So, can you separate it from
You can,
There's an idea.
in my mind, people say, well, that's going to 1, the other's going to infinity, and so that's what I was thinking. But that said, you could do, I mean, statistically, this whole thing, but
No,
not
it is. Put it there.
a million over a million more, isn't that awesome? So I was just kind of, I wasn't doing each of these separately, which actually makes sense what you guys are doing, and I was just doing this right there, that one.
Why are
Or
you
this is going to infinity, so that's the indeterminate on my thought. You could do all of
Well,
this.
maybe I should.
And
wait, did we put
the exponent of the on, this is the way to
Okay. What's the answer to 2?
2 was not on this paper. 1 over 8.
Yes. Okay.
Yep.
It's like, why can't, okay, so I did this, in the x, the denominator, why can't you take the off from there instead of like, so,
Again, I just thought it would be easier to do derivative if I use log rules on this than if I use the tree.
so like 1 over x, so that should be x plus 1, and for x times, and inside, both behind minus, I didn't do it alone.
And 1 is 5 or 6.
Okay?
But I'll just do it.
Whatever, I thought Oh, okay.
So I did it wrong though. Yeah, it's even negative 1.
How did you get that?
Yeah, and
Oh, jeez.
it's 1 over positive and here it's going to be negative, it's going to be 2. So you probably have it
Oh, wait.
You have not.
Okay.
You have to combine.
well, like when it goes down.
What?
0.
Yay. Oh, yeah, yeah. Sorry.
I'll do volume.
So surprising. I can just have the back. Hey, Elizabeth, what's your number? 5 to 3.
3?
Did you get 0?
It's not indeterminate.
Oh my gosh, that's
It's okay, I just did that.
3 isn't indeterminate.
No.
All the other ones?
I just messed up a little bit.
This one's okay,
Yeah.
we're on the
Yeah, I
did like the stuff right.
Yeah.
Or the heart.
I think when you flip also.
I just like lost something. Okay,
Yeah.
You forgot the 4.
No, I did.
So on 47, yeah, I think when you put up the extra.
I just like always like I literally just took it off. Just like it's I just always like the max is 5.
Yeah.
Always no matter what.
I just want to like.
I just want to 3 petals and max is 4.
Oh, yeah, I like these. These are super easy. They just work in my head. The first one was harder to figure out. Did you do it? You got negative 40 and
What makes it rose?
I got negative 1 is n times 40 plus 4 times n minus 1. Yeah, I was like, that's totally. But like, here's what you want to look at denominator. And you look at negative constant. If you look at
No, for 27 it really is.
a constant, like the 40 is pretty constant.
Yeah.
Plus
I don't even
negative 1 to the end.
I don't even know.
Right, 3 months.
40 plus 4
Because what did you change your scale to?
It's just a bunch of fractions.
What did you do?
It's over and
No, it's however many rectangles there are. Well, if you make it why not? Because you're only going to divide that.
Do what?
I don't know.
I don't know.
I think it's a 2. It's gotta be a 2.
And I was
That one would be 6. Because remember signs like that. Yeah, right. That's true.
Yeah, this is really great.
Yeah. Okay.
Just draw yourself.
I know. It's hygiene. Wait, your first which is oh, I guess you'll have more of that degree.
Remember vectors and I don't know like rock thing. See that not telling.
We just like
I'm very big on the polar. No idea.
I look at the Y.
Most of them are just very
Oh, which means
I got 78.
It's your 24%.
Last name Bill is the will report to the capital area for 7 hours. 10th grader's last name A2K will report to the auditorium.
I barely went.
Yeah.
And then 0 plus 1. Yeah, 5 signs. You have to square, right?
Hey, I got it. Yeah.
It's okay. I think I probably just forgot to print that.
It pisses me off.
Push.
Yeah.
It's such a pain in the
It causes emotional distress to my cut off.
That works.
It's like, if you look at history, lots of problems. You can solve that problem. How do we solve that problem? Doing
How many
doesn't even make sense. You're super smart. Have a nice day. Like 40, 54 of these. Thank you. Have a good day. Oh, yeah. Oh, isn't that what you want to do? There's a station.
Double major, yeah. She already, well, I think, yeah, well, I think she already has a minor, and she's like, I actually think so.
Wow.
I think like 2 to 3 is she thinks every class is fun, like she takes 3. But I kind of I work at 4, and then I was like 10. So I was like, yeah, like kind of started major, but the only non major class is taking is one photo class is one photo. I don't know. I got experience for it. That was hard. And then we do. Yeah, so that's kind of what we figured. It was like, so what if we did like 1 to 3 or something like that? Yeah. 1 to 3 or something like that. Okay. Well, we normally get first around 12:30. So then, like at least 30 minutes to like recover around that. Yeah, we can do 1 to 3. I mean, check with other people. Okay, I'll ask them. Well, otherwise, regression. Running out. So, yesterday we were explaining the whole 1.
Ooh, maybe not very. It's best. I don't stare at those symbols well and answer that question. I mostly think of this as numbers. So if it's 0 to the infinity, then you're taking smaller and smaller numbers times themselves more and more times. Well, if you take a small number times itself 10 times or 100 times, it's going to get really small. So that's not indeterminate. That can really only be one thing. Tiny numbers to big exponents must be. So that's why it's not. That's not why it's not. Wanting to be, remember, approaching to the infinity could actually come out a lot of things depending on how fast.
It looks like a cube.
If this went to 1 slowly, the exponent would fast, and it would get really huge. But if this went to 1 really fast, then it would become 1-ish, and this exponent would really goes to.
Try that one out. That one works better for that guy.
Does that make any sense? Yeah. Just think of it. If I took, always think back to if I took. And then we can ask them. I'm going to be lost in that. Yeah, I know, that's what I said. Okay. You're welcome.
So she can sign off my things, right? I don't need to do that on what? Like, I would assume not, right?
Yeah. Good then. So, yeah, I thought, no, I actually used portrait. But I agree that it looks like a cubic. So, to use a cubic to these would be really lucky. That said, I think with the cubic, you'll get error. There might be, is it dead end on all 5 or is it I remember from Canada. You're a genius. Jeez. Great. Is there a way to see the other point, or the other 2 points?
Other 2 points?
Is there a way to zoom out or anything? Basically, it's this. You are getting a very good fit with the cubic, but it's probably a little off on one of the points. And it's not going through quite perfectly. That said, a cubic equation is good. Why are you using
Yeah,
this?
because that was the first.
Oh, yeah. Use a cube. Cube makes sense because
Okay.
that's what the shape of the gas is.
Okay. And then to find the volume is you just plug in for the specification.
This would be, so this would actually be H, and this would be a cube. So you'd have R of H is some cubic equation.
Okay.
Okay? So yeah, now there's how to find the line.
Yeah, I can't see. Okay, there's a zoom setting.
I'll play around with it a little and figure out this stuff. I would like to show that to them. So now your question is how to find the line.
Oh, gee, no gone.
So let's actually.
No.
No, it's there. But there's also the porting one.
Yeah, that's what I use.
Okay, you use that one instead.
Your reasoning is more sounding because cubic is what the shape is. But
So I should use Forte.
quartic is a different.
What does that even mean? The board?
Okay, now why that, I'll explain why Fourth of Week is perfectly tomorrow. Because this I expect it to be a discussion.
Oh, okay.
Now this actually, to do this right, you have to go back and forth. So this, I understand it feels like right within some you're finding area, but you're not really finding area. You're estimating the bottom. Right? So look at here, at height 0, the radius is 2. At height 2, so in terms of estimating, I could do
You guys started this season?
estimation would be
We're supposed to.
and that would be
Talk on it.
Oh, wait, what?
so it's not because you
Have you seen it? It's like,
so you should be doing more
So I just want to read it then.
using
we'll see if I have determination to read it. Scroll on, it's like 8 pages.
Oh, no, it's a whole book. I'm trying to make it good. The right answer.
No, it's like,
He gets here's
It's moving.
bro, it's either now or later. Rather like go sleep.
Catch it for a little while.
Sounds like a breeze. Gotta air out. Run loud as soon as you see something.
Can your Apple Watch do that? Your Apple Watch is not That's fine. Oh, my favorite. See, look, they're already lifting up. What are you eating now? Jesus Christ.
Oh, right. What did we change last night? Changing it a little bit?
Let's go.
Raquel walks in number 4.
You blow over my milk.
You're welcome. Have a good day. Okay. Attendance. County Drive 13, 125, 7, 8, 9, 11. I'm missing 2 people. I'm gonna miss Okay. Taking attendance. How do I feel? Attendance.
And he was like trying to pull it, like they be first and they'd like a rope and harness the rope.
He's still alive.
It was.
Oh, yeah, I was. Normally I'm close. It's just you're the one from we have to explain your views by.
It's all right. That's yeah. They wrote parts. I know.
Again, on the bus.
That's actually pretty
No, not that one.
We've already bought all. Yeah, that's like an
obviously.
And that one was like
Three, 4, 5.
Oh, shoot.